Hey everyone, we are taking notes today, so you're going to need a pencil and paper so you can copy them down. Title of this lesson is Zero and Negative Exponents. So we're going to be talking about both those things, and this is section 10.4. To start us off, I've got a little bit of a review for you, so pause your screen, try these 4 problems, and then press play again to check your answers. And here are your answers. So for the first one, I noticed that it had a division symbol and that we had the same number for the bases, so I knew that I could use my rule to just subtract those two exponents. So I did 3 minus 3, and that gave me 5 to the 0th power. For number 2, I noticed that I had one base and two exponents, which means that I can just multiply my two exponents. And so I showed my work here. 5 times 4 gave me 20, so I've got 2 to the 20th power. On this one here, I noticed I had two bases, but only one exponent, which means I can distribute that out. And so I've got x to the negative 4th times negative 14 to the negative 4th. For my last one, I have two bases and I have two exponents, which means I'm going to be adding those two exponents. So I've got negative 3 to the 4 plus negative 4, which is going to be equal to negative 3 to the 0th power. You might have noticed that I had two problems that came up with a 0 exponent. And there's a very specific reason for that, and it's because it's what we're learning today. So let's take a look at that. So I just used the same problem as before, so I'm keeping my work up here. So one way to solve this problem is to use the rule of subtracting our exponents to get 0. But what does that 0 actually mean? Just like with any other problem, if we expand it out, we're going to understand it better. So what I'm going to do is I'm going to take 5 to the 3rd and expand it. So 5 times 5 times 5. I'm doing that for both the numerator and denominator because they say the same thing. From there, we can cross things out. So cross, cross, cross. It looks like we're left with absolutely nothing, but if you remember from previous lessons, we're not actually left with anything because we can multiply anything we want by 1 and it stays the same. So in reality, we eliminated all of these 5s, but we're left with 1 over 1, or 1 divided by 1, which is going to give us a 1. So since I know that these are the same problems, and I know that these are both valid ways of solving these problems, I can, with confidence, say that 5 to the 0th power is equivalent or equal to 1. And so whenever you see something to the 0th power, you can automatically say that that's equal to 1. So if I give you a problem like 2 times x to the 0th power, I know x to the 0th power equals 1. I'm going to copy down the rest of my problem, so I have 2 times 1, and that's going to equal 2. So this original problem of 2 times x to the 0th power equals 2. So I just did this problem for you. I know that x to the 0th power equals 1, so 2 times 1 equals 2. What I want you to do now is to finish up these 3 problems that I have remaining. So copy them down on your paper, pause the video, and check your answers after you are done. And here's your answers. So you should have gotten 1 for 1, 1 for 3, and negative 5 for 4. So now we're going to get more into negative exponents. So let's figure out what we know for right now, all the knowledge that we have. We just figured out that anything to the 0th power equals 1. I know 2 times 1 equals, or 2 to the 1st power equals 2. 2 to the second power means 2 times 2, which is going to equal to 4. I know 2 to the third means 2 times 2 times 2, which equals to 8. And then I'm going to pause the video and come back with that done. So I just expanded these out and wrote what my answers were. We can also figure this out. So 2 divided by 2 means that we're going to have a 1. So now that we have all of this information taken, what we're going to do is we're going to solve this problem 2 different ways. The first way is going to be our easy rule way. So we've got the same base and we've got a division problem. So that means that I'm going to be subtracting my exponents. So my base is a 2 and I've got 2 minus 5 for my exponent. We know from 7th grade that 2 minus 5 is going to give us a negative 3. So that's going to be my answer up there. Let's try this with expanding it. So I'm going to do 2 to the second, which over here tells me that I write down 2 times. And then 2 to the fifth, I write down 2 5 times. 2, 3, 4, 5. I know from previous lessons that what I'm going to do now is cross out my duplicates. So I'm crossing those out. Again, we're not left with just nothing up here. We're going to fill that in with a times 1 because that keeps it the exact same. And so now I have 1 over, I'm going to simplify this to 2 to the third power because my base is a 2 and I have 3 of them. And so that's going to be my solution for this one. Just like before, we have the same exact problem. We did 2 valid ways of solving it. So I can with confidence say that 2 to the negative third is equivalent or equal to 1 over 2 to the third. So notice the differences between these two answers. This one has a negative sign, and then this one has a fraction. We have the same exact base in both of them. We have the same exact number, but we got rid of that negative sign in front of that 3, which makes it easier to solve. Because when I have this negative 3 as an exponent, I can't just say 2 times 2 times 2, like how we did over here. What we have to do is to get rid of that negative, we write it as a fraction. So we put the base and the number that the exponent has underneath the number 1, just like how we have written here. From there, we can actually solve it. So I know that 2 to the third power equals 8. So I know that this is equal to 1 over 8. So this is the very basic formula of exponents. So it's just what I just said. We have some number, which is represented by an a, and then a negative exponent. We get rid of that negative sign, and then we throw the base and the exponent underneath a 1. We just flip it. And by flip it, I mean we can put anything over a 1, right? So we're just kind of throwing that 1 on top instead. So let's try these 3 problems. For this first one, I see that I have a base and a negative exponent. So I'm going to flip it. I'm going to put that 1 up top. And I'm keeping my base and my exponent. If I wanted to take it a step further, I could say 3 to the third power is equal to 3 times 3 times 3, which is going to give me 27. So I know 3 to the negative third power equals 1/27. Second one, same thing, just different numbers. We know we can put that over 1, so I'm going to do that. To get rid of that negative exponent, I'm going to flip it. So that means that the 1 goes on top, and the negative 8.5 goes on the bottom with our exponent of 2. Since we flipped it, we get rid of that negative sign. Again, you can keep going and simplify it so it's in its simplest form. To save time, I'm going to move on. So for this one, looks a little bit more confusing because we've got a 2 thrown in there. What we're doing for this one is we have to first simplify it. So I know that expanded out, there's going to be a 2 on top and 6 x's. On the bottom, there's going to be 8 x's. So I am going to do this expanded out first just so we can see it. So I have it all expanded out. I'm going to cancel out playing my matching game as much as I can. And I am left with a 2 up top and x to the second in my denominator. If I wanted to do this a quicker way rather than writing out all those x's, especially if we've got higher numbers that are in like the teens or maybe even the 20s, what I'm going to do is, since that 2's up top, I'm going to kind of just pull it away and say that's 2 over 1. And that's going to be multiplied by x to the 6th over x to the 8th. Now I know that this is going to be subtraction, so I'm saying 2 times x to the 6th minus 8th, because I want to show that work, I want to show my process. And when I take 6 minus 8, I get a, oh my gosh, I can't even write. I get a negative 2, so x to the negative second. Just like before, we are going to flip it to get rid of the negative sign. So I still have my 2 to the first, or 2 over 1. And then I am flipping this and getting rid of that negative. So that makes the 1 go on top, and it makes the x to the second go on bottom. Got rid of that negative. Now I can just multiply straight across. So I've got 2 times 1, which is 2, and I have 1 times x to the second. So x to the second is going to go on bottom, and that is going to be my final answer. It matches up exactly with what we had before. Here are 2 problems for you to try. If you need a little bit of help, because I know this is a really hard topic, go back and rewatch the questions that I just did. If you have to expand things out, I don't mind. And here are my answers. So the first one, we've got x to the 0th power, which means that I have a multiply by 1 there instead. So negative 5 times negative 1 gives me a negative 5. For this one, to keep it easy, all I did was I noticed that this has a negative sign on it. So I can't have any exponent that has a negative. So what I did was I just took the exponent in the base and I flipped it to the other side of the equation. And so that's what you can see right here. So I was able to get rid of my negative sign by flipping it to the other side of the fraction. From there, I know how to do this. Because there's 2 bases and 2 exponents, we're going to be adding our exponents. 5 plus 3 gives me an 8, so I've got 9 over y to the 8th. The 9 stayed because there was nothing I could do with it. That y to the 5th stayed because it did not have a negative exponent. It just stays on the bottom there. If you've got any questions about this section, make sure that you email me. Your homework today is on IXL, so it's going to be able to tell you whether you got the question right or wrong immediately. So if you realize that you're missing question after question, please talk to me about this section. I know it's very difficult to understand at first. So if you are having trouble, it's no problem at all. Let's just work to solve it.